wanted to go over this example is this has a depreciation of 10% each year. We did a question with an increase where the population increased by 0.8% and we multiplied by 1.008 as a result of it. Now we're looking at a depreciation. So this is, I mean, if we look to a real life example of this, you go to buy something at the store and there's a sign that says it's 10% off. So you have to figure out how much is it going to cost. So if it was regular $35, one way of figuring out how much it would cost is you say, what's 10% of $35? That's $3.50. I subtract that off the $35, and I now know it's going to cost me $31.50. Okay? That would be a 10% deduction. In this case, we've got something that depreciates. When you buy certain things, they're not as worth as much as they were when you bought them, right? Brand new cell phone. How much is a brand new cell phone worth in 1 year, in 5 years, in 20 years, right? In 10 years. Think about 10 years ago. What was a brand new cell phone 10 years ago? Was it a flip phone? Where you had to text by going AAA, BBB? Was it not even a smartphone? How much are those phones worth now? Nothing, right? Because they've depreciated in value. So, here we have a farmer in Saskatchewan wants to estimate the value of a new combine after several years of use. New combine is worth $370,000, okay? Today's value, we could look it up. It's probably even much, much more to buy a new combine. Depreciates in value by 10% each year. So, what we're going to do here to analyze this is to create a chart. We're going to put value and time. So at the start, the value is 370,000. At the end of year one, we would have to take 10% off. Now I want to show you a calculation, okay, because most people when they take 10% off, they would do what we discussed when I talked about the shirt or the $35 item being 10% off. Most people take the $370,000, they multiply by 10%, which is 0.1, to get $37,000, and then they find the new value by taking the $370,000, subtracting the $37,000, and getting $333,000. Now mathematically, and just open up my calculator on the screen as well. Mathematically, what we're doing when we take 10% off of something leaves us with 90% of the value. Does that make sense? If you take away 10% of something, you're left with 90%. And this can cause us to do this calculation a lot quicker and a lot easier. If you're buying something for $35 and it's 10% off, you're going to be paying 90% of the original value. So if I would take $370,000 and say what's 90% of its regular value, that would be multiplying by 0.9, I get the $333,000 in one calculation, which is way better than taking 10% and then subtracting it, right? So now when you go to a store and something is 25% off, you might instead try to figure out what 75% of the value is. multiply by 0.75. And you might actually say to yourself, I like fractions better than decimals because 0.75 is 3/4. So if something was $20 and it's 25% off, 3/4 of 25 of $20, well, I'll divide by 4 to find out what 1/4 is, times by 3 to get 3/4, $15. So that can help you with some of your mental math. What's also very nice about the 0.9 is we can fill in our chart a lot quicker. So we need, in part A, 5 years, end of each of the first, end of year 2, I'd go to my calculator, I would take that answer and times it by 0.9, 299,700. 299,700. And then I start getting lazy. I take out the word year when I write. So end of 3. Something nice about calculators. Notice how I just did times 0.9 the last time. It took my previous answer and multiplied it by 0.9. Now, if you've got something in there where it says answer times 0.9, if I just push enter, it does the same thing I had last time. Answer times 0.9, so 269,730. End of year 4, go to my calculator, I just push enter, 242,757. And end of year 5, 21848130. And since we are, right, if we do an analysis of what we did, we went from this one to this one by multiplying by 0.9, by multiplying by 0.9, by multiplying by 0.9, by multiplying by 0.9, and by multiplying by 0.9, we made a geometric sequence here. What is the formula for this geometric sequence? Well, the formula for this geometric sequence is term 1. If we use our starting value for term 1, what are we multiplying by each time? 0.9 to the n minus 1. Another reason, so first of all, the depreciation, the percentage off, knowing these ideas that maybe you've never thought of before. Maybe you always did 10% and subtracted, never thought of doing 90% of the regular value. Huge skill to have. Secondly, in part, what type of sequence did you write? Okay, it's geometric, we did that. In part C, predict the value at the end of 10 years. Here is another place that not only do students make mistakes, but I got a question bank from the company, and whoever did the answer key on every single depreciation question made a mistake. So one of the reasons I wanted to do this one with you as well is I want to check. I think in the textbook they did it right, but when they made their test questions, they did it wrong, which won't affect you because I'll have the right answer when we do our test questions. But in part C, it says find the value of the combine at the end of 10 years. You have to be careful. Most students go, okay, I'll find term 10. But look at our sequence. What did we make term 1? We made this term 1, this was term 2, this is term 3. So the end of year 2 was term 3. If I want to find the end of the 10th year, which term do I need to find? Term 11. So then term 11, as far as plugging it into the formula, that part is okay. I'd go to my calculator, 370,000 bracket 0.9 to the power of 10, because 11 minus 1 is 10. Push enter, $129,011. Did the answer key get it right? That's question 1. Yes. So the textbook was good, but the program they sent out afterwards to say, hey, teachers, you should use these as questions for your test. And if those teachers then used their answer key was wrong. So we have to be careful. Textbooks will have wrong answers. You check, like I'm guarantee there's some answers in the back of the book of this one that aren't right. Teachers will make mistakes, I guarantee. If I make it through this whole semester without making a mistake, then I guess I'll have to retire, because it's like winning a championship. You got to quit after that, right? No. So mistakes happen, but you want to check them. When you see a mistake, you have to ask yourself, did I make a mistake? Right? Generally speaking, you check the answer in the back of the book. If your answer is wrong, you probably made the mistake. That's what statistics would say. Okay? Then you check your answer again, and if the answer keeps coming up, then you start to question, I think the textbook made a mistake.